Hey everybody, and welcome to my channel. I want to show you today my latest project. I've made 3 solid state Tesla cores, all single resonant. So I wanted to try my hand at a double resonant coil and finally come up with a driver board, which is shown here. It has an optical input, which is that one labeled fiber right there. I can run it off of 12 or up to 12 to 15 volts, which is put in here. And here's my power supply with some, I've doubled up some 7812 voltage regulators. I've got a 5 volt voltage regulator, so these are doubled up 7812s, and then there's my 5 volt. I've got some smoothing capacitors and bridge rectifier right there, and I got one big capacitor here. It's 22,000 microfarads, 50 volts, and that goes in here. And then I'm using for the fiber optics, I'm using a FB142ND fiber optic receiver, and this is just a fiber optic cable right here. And I'm using red light, so I'm using a red LED to transmit into this. And then this circuit's based on Steve Ward's work. Because this one gives an inverted output, I had to switch the pins off of this, so instead of the pin number 7 going out to my UCC MOSFET drivers, I'm using pin number 6, so I get my output, a positive output instead of an inverted output. A positive output would leave the MOSFET switched on most of the time and destroy them. And then I'm using 3 microfarads of ceramic caps, and then it's clamped to either 12 or 15 volts with these diodes here, these fast diodes. And I've got a little indicator light also wired into the circuit right here. And this is connected between pin 6 on here, and the ground. So when this gives a square wave, this flashes. So I'm getting light impulses going in here, and those are being converted to square waves by this hex inverter, which then goes to this 74HC109N here to give me square waves here. And this has also got an OCD over current protection built in right here. So the circuit is right here. This is off of Steve Ward's website. And the only difference I've done is instead of connecting pin 3 on the UCCs to pin number 7, I'm connecting it to pin number 6 because I'm using this fiber optic, which gives you an inverted output. That's the only difference. And then I added an indicator light, as I mentioned, between this pin number 6 and the ground, so this flashes when I have input. So I'm going to test it out and let's see how it goes. Okay, now I have the circuit powered on, and you can see that the red indicator light, the LED is flashing because I'm getting pulsed input from my pulsed generator from my interrupter, which is right here. And that's going into the fiber optic receiver. And so what we'll do is we're going to probe some of the various pins and see what it looks like on the digital oscilloscope. So the first pin that we're going to probe is pin number 9, which should be the same as the output from the optical receiver. So here's number 9, and it should be making, let me get it connected well, it should be making inverted square waves, which it does. So number 10, the way that this is wired up, should also give inverted square waves, so let's look at that. And so yes, we're getting inverted square waves off pin number 10. Now pin number 10 is connected to pin number 5 of the 74HC109. So let's look at what 5 looks like, and that should be exactly what 10 looks like. So should be inverted too. So let's see what that looks like, and we're getting inverted waveforms. So pin number 6 should give you square waves the right way up. So let's look at what pin number 6 does. 4, 5, 6. So there's 6. And we're getting nice square waves. One of the problems we're getting there is some ripple, some kind of contamination, which is not good. And now let's look at the outputs for the output pins are 6 and 7 of each of those UCC 37321 and T2. So let's look at pin 6 and 7 of the 21. And we're getting nothing. Now let's do the same thing with 22. And it's got a voltage on it. It's probably 12 volts. But it's also showing no pulsed output. So that is not good. So now I'm going to turn off. Actually, before I even turn it off, I'm going to measure the voltage at the pin 3s to see what those are. They should be 0 if I turn off the pulse. So I've got nothing on there. Let's see what the pin 3 voltages are on these UCCs. So here's pin 3 on the 21, the UCC 37321. We're getting 0.69, 0.7 volts on that. Now let's try UCC 37322. And on that one, we're getting about 0.7, 0.8 volts as well. So both of these pins are on. They're somehow picking up some kind of voltage off of pin 6 on the 74HC109N. So some planned things that I'm going to do to try and get around this problem is to put a diode or maybe 2 diodes in series, and the voltage drop on those diodes should get rid of any abnormal noise that the UCC MOSFET drivers are seeing. So I'm hoping that will work. The other thing I could try is like a capacitor, ceramic capacitor, like 5 or 10 microfarads. So that is the planned next step in this project, and I will keep you up to date in my next video. Thanks for watching.